Hello everyone. Today we perform virtual lab intelligence theorem. How to perform virtual lab intelligence theorem. I want to share my PPT here. First, how to perform intelligence theorem. First you go site. The name of the site is vlab.iitkgp.ac.in. In this, the virtual lab home and go for analog signal network and measurement laboratory. And then go to the list of the experiments. In the list of experiment, there are several experiments. We go for verification of intelligence theorem. In such, we see here first, this is a theory of intelligence theorem. Already we have see here. First, objective is what? Objective is to verify the intelligence theorem. We know that very well how to verify the intelligence theorem. For a given time, if the current value is equal to IPQ and node is P and second node is Q and the branch is K. Now, the current is IPQ flowing through the K between P and Q. For given time, the sum of power delivered to the each branch of any electric network is zero. Thus, the kth branch, this theorem state that कि अगर हम किसी kth branch पर ये वैल्यू निकाल रहे हैं, then Vk into Ik is equal to some constant value 255, as you know. Now, n being the number of branches. Number of branches कितनी हैं? That should be counted by n, where Vk the drop in the branches and Ik the through current, while Bp and Bq are voltage at P and Q nodes we have. Now we can write such thing like this, means the total voltage across this node is equal to Vk and the total current across this branch is equal to K branch is equal to IPQ. So we find out here the total voltage, the value of total voltage is equal to what? The value of total voltage is equal to what? The voltage of P node and the voltage of Q node. So the total branch voltage is equal to Vp minus Vq. So we can write here Vp minus Vq into total current IPQ. Just we have to write here. Now in generalized form, you can write Vk into Ik, number of branches that will given into the circuit. Also, you can write this Vk into IPQ is equal to Vq minus Vp into IQP. If we find this voltage from this side to this side, then you can write the total voltage of this branch is equal to first node is Q and the second node is P. Then you can write this on this manner. The voltage is equal to Vq minus Vp and the current is equal to I from Q to P. So we can write here IQP like this in equation second. We can write Vk into IPQ. So if the current direction is different, then you can write Vq minus Vp into IQP. Means what? The IPQ direction is opposite to IQP. So we can write here IPQ is equal to minus IQP. Summing the equation first and second. When we are summing the equation first and second. The value is equal to 2 into I 2 into Vk into Ik is equal to Vp minus Vq into Ipq plus Vq minus Vp into Iqp. You can write this like this manner. In the fourth equation, we can see here what 2 is right hand side, shift to right hand side, and we can write such equation like this: Vp minus Vq into Ipq plus Vq minus Vp into Iqp divided by 2. This is equation 4. Equation 4 can be written every branch of the network. Assuming n branch generalized, जनरलाइज करेंगे हम इसे आई के रिस्पेक्ट में. वी कैन राइट दिस ऑन दिस मैनर व्हेन summation of vk into ik k from 1 to n, then you can write like this. कैसे? summation of p की वैल्यू 1 to n and q की वैल्यू from 1 to n. अब यहां पर 1/2 है कांस्टेंट, जस्ट वी कैन आउट फ्रॉम आउटसाइड, बाहर की तरफ हमने लिख दिया. और इसके बाद क्या किया, इन द ब्रैकेट वी कैन राइट हियर इन दिस ब्रैकेट Vp minus Vq into Ipq means the value of P change from 1 to n and the value of Q is changed from 1 to n like this. And every changes you can write here the summation of all these values should be present here like this. Here we can write such manner. Here this value can be changed like this when summation of Vp from 1 to n and the summation of Ipq from 1 to n minus half of summation of Vp and the summation of p from 1 to n Ipq. Just you can write this like this. And then here, if following Kirchhoff's current law, अगर Kirchhoff's current law follow हो रहा है on the node, then you can write the summation of Ipq from 1 to n, the exactly constant value, and the summation of from current Ipq from such type of equation like this, then this constant value is equal to 2 something, whatever the value given there, this is equal to. Now equate the equation 6 and 7, the value is equal to क्या हो जाएगी, substituting the equation 6 and 7. Now we have to perform this. क्या कि summation of Vk into Ik from k to n is equal to some constant value, and this is the 8th equation. Just we can write. Now in the equation 8, show that the sum of the power delivered to the closed network is 0. This power Tellegen theorem and also validates the conservation of power in any electrical network. It is also evident that the sum of power delivered to the network is equal to the sum of power absorbed by the passive elements. ये यहाँ पर हमें क्लियर हो जाएगा कि जो भी पावर हम यहाँ से डिलीवर कर रहे हैं, एग्जैक्टली द सेम पावर इज absorbed by the passive elements. Such case shows that the Tellegen's theorem proved. Now, such case we want to prove, we are going to solve here with the help of simulation. We can see here there is the operating environment. We know that here is the procedure. There are several resistances present in this circuit. There is a one voltage source, 220 volt DC voltage. Now here one resistance present, one ammeter present for calculating current. One resistance is also present over there, and one ammeter is also present here for finding the value of current. Now we move here to see one resistance is also present over there, and here one ammeter are also present here for calculating the total current in this network. And after calculating current, multiplied with this resistance and calculate the value of this voltage here. Now, such type we can find out. There are some procedures how to find out, connect the circuit shown in the circuit diagram above, keeping switches open and resistances at their maximum position. केस फर्स्ट, प्रेजेंस ऑफ बोथ द सोर्सेस। हम डायरेक्टली सबसे पहले दोनों सोर्सेस को प्रेजेंट करके इसमें टोटल वैल्यू ऑफ द पावर डिसिपेटेड कैलकुलेट कर लेंगे। उसके बाद नाउ सेकंड केस, प्रेजेंस ऑफ V1 के थ्रू हम वैल्यू को कैलकुलेट करेंगे। और अगला केस, जब केवल और केवल V2 प्रेजेंट होगा तब इसकी वैल्यू वी वांट टू कैलकुलेट, तब हम V2 के केस में इसकी वैल्यू को कैलकुलेट करेंगे। उस केस में स्विच S1 इज शॉर्ट सर्किटेड एंड S2 इज, क्या करेंगे हम उसे पावर सप्लाई से कनेक्ट करेंगे। केस सेकंड में क्या करेंगे, व्हेन द प्रेजेंस ऑफ V1 ओनली, जब V1 ओनली को प्रेजेंट करेंगे तो S1 इज कनेक्ट टू पावर एंड S2 कनेक्ट टू द शॉर्ट सर्किट। तो इससे हमें क्लियर हो जाएगा फर्स्ट वैल्यू के थ्रू, इसी तरह से सेकंड वैल्यू के थ्रू भी हम आइडेंटिफाई करेंगे और ये वैल्यूज को कैलकुलेट करके हम टेलीजेंस थ्योरम को यूज करेंगे। जब वैल्यूज हमें सेम मिल जाएंगी मींस कि यहाँ पर टेलीजेंस थ्योरम स्टेट एंड प्रूव हो रही है। अब इस चीज को करने के लिए हम वी यूज अ सिमुलेटर। नाउ सिमुलेट सच type of circuit here. Click to perform the experiment. We have to see here there is a circuit, how to perform such circuit. Everyone see this circuit? सबको दिख रही है सर्किट? सबको ये सर्किट शो हो रही है?
Yes, sir.
Okay. Now we have to see the experiment part select. सबसे पहले हम एक्सपेरिमेंट पार्ट को सेलेक्ट करते हैं और इसमें फर्स्ट वी आर गोइंग फॉर द केस फर्स्ट इन द प्रेजेंस ऑफ बोथ द सोर्सेज। हम यहाँ पर देखेंगे देयर आर द टू सोर्सेज प्रेजेंट ओवर देयर। द फर्स्ट सोर्स इज S1 एंड द सेकेंड सोर्स इज S2। द वैल्यू ऑफ दिस सोर्स इज 220 volt present over there. Now here we have to see the first resistance connect over there is 100 ohm and the second resistance is connect over there is 150 ohm and the third resistance is how much, 200 ohm. Now here the second power supply is connected over there with the 110 volt. Now we have to identify this circuit with the use of case first, determining the branch current in the presence of both sources. Select the both the switches S1 and S2 to power supply. दोनों को हम पावर सप्लाई से कनेक्ट करेंगे। नाउ फर्स्ट इज कनेक्ट टू द पावर एंड सेकेंड इज ऑल्सो कनेक्ट विद द पावर एंड देन when we simulate this, then the power of first resistance should be calculated here, power of second resistance is also calculated here, power of the third resistance is also connected over there, the power of first voltage is also here, V2 is also here, means here the source power is also here. We can find out here the source power and now here the power of second voltage source is there and every reading you can calculate with both switches connected over there and we can find out all values is there. Now we can simulate here. After the simulation we can see here the first resistance power is minus 71. The first resistance power is minus 71.597633. This is the first resistance power and now the second resistance power is what the second resistance power is minus 4.2958579 is the second resistance power, and the third resistance power is 90 minus 91.644970. Now we have to calculate the power of the sources. The first power of the source is equal to 186.15384, and the second source power is equal to minus 18.615384. When we calculate all these things in the addition form, the result of summation is equal to 0. Means the Tellegen's theorem exactly says that all powers value should always equal to 0. The summation of all all powers is equal to 0. Now here we see this, the result of this summation is equal to 0. Now we go move for the case second and solve these things for the presence of first voltage only. The switch S1 is connected with the power, S1 is connected with the power, and S2 connected with also what, S2 connected with the short circuit, and we can calculate the total power for the first voltage source is what we can calculate here. Now we see here the result determining the branch current in the presence of only first voltage source only. Select the switch S1 to power, switch 1 connect with the power, and S2 is connect with the short circuit. So then we have to connect S2 with the short circuit, and then we go for simulation. Now we have to see this, the power of first resistance. The power of first resistance is equal to what? The power of first resistance is equal to minus 140.33136, and now the power of second resistance is equal to, the power of second resistance is equal to minus 68.733727, and the power of third resistance is equal to, the power of third resistance is equal to minus 51.550295. And now only one source is present over there. Now we have to calculate the power of first voltage source is equal to 260.615384. After the calculation of total voltage, total power of this network is equal to 140 plus something, whatever value should be present over there, we have to add all these values, and the result of the summation is equal to 0. Means this circuit follows the Tellegen theorem. Now we move to the case third. What is the case third? In this case, we have to solve by the use of one voltage source that should be present over there in the V2 voltage source, short the V1 voltage source and connect with the power V2 voltage source, and find out all these values should be present over there, the values of first resistance power, the value of second resistance power, the value of third resistance power, and the total power present over the source, second source, that should be counted by the simulation. Just we have to change here, the first voltage source is short circuited and the second voltage source is connected with the power. Now we have to simulate here. After the simulation, we have to find out the first resistance power is equal to minus 11.455621, and now second resistance power is equal to minus 38.662721. This is the power of second resistance. Now the third resistance power is minus 5.7278.1.106 is the third resistance power, and after calculation of this, we have to calculate the power of the second source is equal to 55.8461538. and then we have to calculate the summation of total power. The summation of total power is also equal to 0. So we know that very well this circuit is justify, yeah, verify the Tellegen theorem, because all power sums are equal to 0. Now fill the data into the table. After this, we have to see here the data filled into this table. We know that the first power by when the presence of V1 and V2 present over there, the power of first resistance is equal to minus 71.5, and after this we have to calculate the value of second resistance power. The second resistance power is what? The second resistance power is minus 4.29. Like this, the power of third resistance is equal to minus 91.6, and power of first voltage source is 186.1, and power of second voltage is minus 18.6. If we add all these things, the value should is equal to 0. And now we have to move for the second case. The second case is only V1 present into the circuit. Now calculate all these things: the power of first resistance, the power of second resistance through power of third resistance, and the first source only the present in the circuit. The first source power is also present over there. We have to count all these values, and we can satisfy the condition of intelligence theorem. Now we can prove for the V1, and after we can prove for the V2 also. So we can write each and every values should be present over there. The power values for the only V1 present, the power values only V2 present, and power values all for V1 and V2 both present in the circuit. So we can find for three cases all these values and satisfy the condition of Tellegen's theorem. So we can say that this is the verification of Tellegen's theorem. If now we can change these values and perform once again like we want to perform here, the first voltage source we have to moderate. The value is equal to 230 volt. The V1 set it here. First value we can set here. V1 is equal to 230 volt. The resistance R1 is equal to 110 ohm, and second resistance is equal to 165 ohm. Third resistance is 215 ohm, and this voltage is equal to 125 volt. Now setting of these values, we can perform the virtual lab like this. First case, in the first case both switches connected with the power. The first circuit is connected with the power, and second circuit, second voltage source is also connected over there. We can find out the value. How to find out this value? Simulate this. After the simulation, we can see here the power of first resistance. The power of first resistance is equal to minus 67.481426, and the power of second resistance is equal to minus 2.1519656. This is the second power of the second resistance power. Now the third resistance power is equal to minus 96.236876, and the power of second first voltage source is equal to 180.145583, and the third second source power is equal to minus 14.127535, and the summation of all these results, P1 plus P2 plus P3 plus PV1 plus PV2 is equal to 0 means this circuit perform the Tellegen theorem and verify such Tellegen theorem because all power addition is equal to 0. The case second, when only one source present over there and the second source is not present here, so we can short the second source and simulate all these things. First source connect with the power and second source connect with the short circuit, only one source present over there. After this we can solve simulate such result. The result of after simulation, the power for the road, power for first resistance is equal to minus 140.71406 and the power for second resistance is equal to minus 67.567602 and the power of third resistance is equal to minus 51.854206 and the power with the voltage is equal to 260.135878. This is the power of this voltage source and after the calculation of all these powers, all the summation of all these powers is equal to 0 means this circuit verify the Tellegen theorem. And now we move to the case third. In case third, the values of these resistances are still same and the power for second power we use, second voltage source we use and first voltage source we can short here and the second source connect to the power. Now we can simulate such network. The value should be present over there. The P1 for power for first resistance is equal to minus 13.304899 and power for the second resistance is equal to minus 45.602921. Power for third resistance is equal to minus 6.80715779 and next power for second voltage source is equal to 65.71497889. After the calculation of all these powers, summation of P1 plus P2 plus P3 and PV2 is equal to 0 means this network is also verify the intelligence theorem. And after this, we have to fill data into the table. After the filling the data, we can see here the second reading is also present over there. Here, the P1 for power for first resistance is this, power for second resistance is this, power for third resistance is this, and power for first voltage source is this, and power for second voltage source is minus 14.2 is this first. The first case is the presence of both voltage sources. For first voltage source V1 and V2, for the second voltage source both sources present over there. The values of the power for resistance first, values of the power of resistance second is this, and the value of power of third resistance is this. Value of first voltage, power of first voltage is equal to 180.10, 180.1 and the power for second voltage source is equal to minus 14.2. After the calculation of this, summation of the value is equal to what? The value is equal to 0. We can write here and calculate all these things from such type of things. Now we have to move for the second case. Here we can solve how to solve this by the use of only the V1 present over there and how next another case only the V2 present over there, the V2 and such case we can find out all these things by the use of only V1 and only V2 एंड व्हेन प्रेजेंट V1 एंड V2 बोथ। हम इन सारी चीजों के लिए तीनों केसेस के थ्रू फाइंड आउट कर सकते हैं कि अगर फर्स्ट केस में बोथ सोर्सेज आर प्रेजेंट ओवर देयर, व्हाट इज द वैल्यू, वन ओनली वन सोर्स प्रेजेंट ओवर देयर, व्हाट इज द वैल्यू, एंड व्हेन only one source, only V2 present over there, what is the value, we can find out. यहाँ तक किसी को कोई प्रॉब्लम है? Anyone any problem? Just you can ask me. किसी को है यहाँ तक कोई प्रॉब्लम? सबको समझ में आ रहा है? Everyone understand?
यस सर।
कहीं किसी को कोई डाउट हो तो पूछ सकता है। समझ में आई कैसे परफॉर्म करेंगे वर्चुअल लैब? इंटेलिजेंस थ्योरम को कैसे वेरीफाई करेंगे? समझ में आई बात?
यस सर।
हाँ, ओके। तो इस तरह से हम लोग इंटेलिजेंस थ्योरम को